recognize this saying? One, maybe two. Okay. Not too many, right? So what we're talking about here is object orientation. Obviously. Not obviously, but it is object orientation. And it is about sending messages between objects. And telling objects what to do rather than ask them for a lot of information and then decide what you would like to do. So, sending messages and method call is a message. So in this case, I'm sending a message to some kind of customer object and I get some kind of result. So that's sending a message. This concept was, I guess you could say, popularized by Andy Hunt and Dave Thomas in the book Pragmatic Programmers a long time ago. This is a blog post they wrote where they describe it as well. A lot of people did think about it a lot, and it's the main, no, not the main, it's an important part of the book Growing Object-Oriented Systems Guided by Tests by Steve Freeman and Price. How many in here has read that book? How many in here has heard of it? Okay, you guys. Right. Alex Sharp, author of Smalltalk by example, defined like this. Procedural code gets information and then makes a decision on what to do. Object-oriented code tells object what to do. And there's a big difference here, because if you just tell someone what to do, then you don't have to have a lot of knowledge about the underlying system. You just tell someone, get me coffee. I don't care how you make the coffee. Bring it. This is also very closely related to something called Law of Demeter, often abbreviated LOD. So, next question obviously, how many has heard of that one before? Oh, pretty much the same people. Okay. Maybe you read the same books as I do. Law of Demeter is something that defines how we should interact with other objects. So, method of an object should only involve the method of the following kinds of objects. That is, itself. It's okay to have knowledge about yourself. It's okay to have knowledge or use your parameter that you send into a method. Objects you create. And in private instance variables. And that's it. So you're not allowed to ask someone and then get a result, and then ask that result for something, and then ask that result for something. That is breaking Law of Demeter. Some people also claim that it's okay to access or use global variables. I don't agree. That should be illegal, but for some reason it isn't. Not yet. Other definitions of Law of Demeter could be something like this: only talk to immediate friends. Or an advice I would give to kids: don't talk to strangers. Right? So what we're interested in here is not telling, or it's not interrogating stuff, or asking for a lot of information. It is focusing on the interaction between objects and how we can do this in a good way without creating mess. That's our goal. So, in a sense, you should try to be polite. Do not reach into a collaborator and poke around for the information you need. Do not write code like this. We have some kind of television, it has some kind of front panel, switch, and then there's power switch, it could be on and off. A method call like this is highly illegal. Something a lot better would be this, power on. So it's a matter of lacking abstractions in many cases. This example clearly lacks a lot of abstraction. It's possible to work with code like this, but it's unnecessarily complicated. So this is a lot better. So the question now is, why do I even care? Why do I think you should care? Well, in my case, I was working for a large train operator in Sweden. We were booking a new seat booking system. We were writing a new seat booking system for them. The old one worked. It was written global, and there were licensing issues that didn't allow them to traffic, say Denmark in this case. So, and they wanted to run red trains through Denmark as well. So therefore, they had to build their own seat booking system. Okay? Quite simple domain, or at least one could think so. We didn't deal with trains, we dealt with transports. Units, carriages, well, I'm not really sure about the English word here, can also be connected to unit groups. And in that you have a compartment, and in that you have a place or a seat. So what was our problem then? Well, we had the wrong abstractions, and we were missing a lot of abstractions. So stuff was tangled. So if I would like to find some information about my favorite seat on the train to Gothenburg, I used to travel to Gothenburg from Stockholm for a year. That would be coach 5, seat 18B, which is located at the table, and your travel will be back in the traveling direction. I had to do something like this, which I don't even think you can read. So I had to get the transport. I had to ask it for a unit group. I had to ask it for a unit, a compartment, and then finally a place. So the code that we were dealing with could look like this. This is also known as a train wreck, because if something goes wrong here, you don't really know where. Say that one of these method calls returns something undefined. You would get a null pointer exception in Java. You don't know which part that broke. Therefore, the expression train wreck. The thing that I would like to do looks more like this. I'm interested in this specific seat. Don't care about the details. Definitely don't care about how you look them up. We didn't have these abstractions. And I didn't even realize it until it was too late that this was one of the reasons why we had so much problems understanding what we were doing. We had a lot of performance issues as well, which we found out very late. But the performance issues was not due to breaking Law of Demeter. Breaking Law of Demeter just made it very complicated to fix, because everything was connected. You couldn't do anything without changing a lot of things. So what I would like to have done was something like this. Get me the seat. I don't care. So tell in this case, the transport, do whatever it takes to get me the information about this specific seat. So adding these abstractions would have been really easy. For bad reasons, we didn't do it. So when I describe what I'm going to talk about to a friend the other day, he said, it sounds like bureaucracy. You're talking to someone in some kind of office somewhere, probably, and they send you to the next guy. Who will send you to the next guy? Who will send you to the next guy? It's just bad. No one, except very few people in the world, like bureaucracy. And I would assume that the guys working within it, they might like it because it will give them something to do and some way to pay their mortgages, but that's about it. It's a lot better to go to a government agency, whatever, and get what you need directly, instead of jumping around between all these different departments. So again, why should you not break Law of Demeter? We don't want to deal with tangled objects. We don't want our code to look like this when we have to do a change. We want to be able to do small changes, but if we have a situation like this, it's just bad. So this is a good reason why we shouldn't. Tell don't ask also helps us to avoid feature in the objects. The functionality should be spread in a reasonable way, whatever reasonable seems to mean. But this is not the situation we want. I mean, this kid is probably very happy. He has all the toys he needs, and then some. But it's a lot better to distribute it a little bit. At least it will get a lot easier to clean up this room if he has the stuff in different boxes in different places. It will also break encapsulation, and therefore it will be hard to change stuff. I pretty much know what will be inside of this doll, but I don't need to look at every piece to get some kind of information from it. So, how can we avoid this? Well, to start with, static code checking. We do that? Probably. Or, I don't know. This is an instance of design, a good design. So I'm not really sure. But thinking of it, yeah, it could be possible to find a syntax tree where we actually can recognize that this object is calling some other object that is calling some other object in a long chain. So it might be possible. I have never seen a tool that would help me though. And I've been looking for it, because it would be really interesting to run on some code bases. And I think the definition of good is kind of vague sometimes. What is good design? Sundberg talked a lot about that yesterday. And it's a matter of opinions. We probably will disagree on what good design is if we really look at all the details. But on a high level, we probably will agree. So it's kind of vague, and therefore it's complicated for a tool to tell us this is good design and that is bad design. Okay. What about the practice then? Are there any practices that could help us? I'm a big fan of system development, very big. And I have always had the opinion that this will lead to good design. I have, however, started questioning that after conversations with among other Sandra, and come to the conclusion that it doesn't necessarily lead to good design. So therefore, test-driven development may or may not prevent you in this situation. In the system that we were working on, we had a lot of tests. Too much of it was written afterwards, but there was some that was written before, and so test-driven. But the design was, in many places, not good at all. It's actually horrible. So different TDD styles will help you in different ways. And as we heard yesterday, there are two main flavors. We have the Classic and the Mockist version, or we have the Chicago, Detroit school and London school. They are different in the way that the Classic one is interested in checking the state. That's very easy to do in some cases, and it's not that easy in some other cases. And if we're only checking the state after a while, and we should sort something, we could definitely end up with a bubble sort. Because the state is what we're looking for. Bubble sort may be okay, but there could be other solutions to the same problem. Or actually, we all know that there are. The Mockist approach, when you do that one, you tend to go from the outside to the inside. You have some kind of loop, double loop, where you write some kind of acceptance test or something similar, and then you write smaller tests in the middle, driving out the functionality, but you always start from the outside. And therefore, you focus on the interaction more than you focus on the state. And doing this make it perhaps a little bit harder to fail on Law of Demeter. But of course, if you really want, you can definitely fail on it anyway. So, given the different styles, if you want to really avoid breaking Law of Demeter, then the Mockist style is probably better for you. But it's still just a matter of the implementation. So if you know what you're doing, then you can still avoid it no matter which method you or which way you prefer to write your test. Okay, the 4 rules of simple design, will they help us? Let's start with checking which are they. Well, these are the 4 rules of simple design as defined or described by Kent Beck in the XP Explained book from '99 or something like that. It says tests should pass. Well, that's good. That means a couple of different things. But it means that we don't allow tests to fail, and it also means that we have tests. That's good. Code should reveal intent. It should be very clear what we mean when we read the code. So good naming, good variables are very, very important. We should also avoid duplication. And things should be small. Well, test passes. Will that help us not breaking Law of Demeter? No. Because it doesn't really matter from the test perspective how we have implemented the system under test, the production code. So, test passes, nope, not enough. Reveal intent? I would say yes. Because it's harder to understand the intent if you have to follow a train wreck and understand each call there. You could probably have good abstraction with a good name instead. So yes, reveal intent would probably help us. No duplication? I would say yes. Because if you try to interrogate a collaborator for a lot of details, say that you should calculate the risk in the insurance system, and you're interested in the age of a person, how long time has this person had a driver's license, are there any accidents in this person's history. You could obviously ask the system for that many times and then make a decision. But it could perhaps be a better idea to have some kind of abstraction on a customer object or something similar that will just give you the give you the answer. The risk is this number, given all these factors obviously, but the guy needing this number, the method needing this number, doesn't have to know the details of how you calculate it. So that's an abstraction. And interrogating something would lead to duplication, so yes, no duplication will help us. Small, I would say probably. Because if you interrogate an object, then this will take a lot more code to write there, and therefore breaking the rule that stuff should be small. And then there's obviously interesting definitions here. What is small? I don't know. It's not large. That's not a really good definition. So everyone will have different opinions on this one. So this is something that can be debated. What is what? But 3 out of 4, 75%. I don't think that's bad. So studying and understanding the 4 rules of simple design is something that could be really good in this case. So let me try to explain again with a small example of why you don't want to do this. Let's take the situation, you buy paper somewhere. From Paperboy, or I don't know if we have that, you have that here in the UK, never seen it in Sweden. But think of a store, or whatever, you buy a paper. So we have someone selling a paper, we have a customer, and we have a customer's wallet. If we try to implement this just using state verification, we could try to test something like this. We create a new instance of a Paperboy. We define that the payment should be 2 in some kind of currency. And we check for the initial state of the Paperboy. How much money does this Paperboy carry? Get money is perhaps not a perfect method name here, but yeah, that's what I came up with. And then we should expect some kind of result. That would be the initial number, initial amount of cash this Paperboy is carrying, and the payment that the customer should give it to you. All right, and then we create a wallet that we assign to the customer, and we place 10 in that wallet. So we have 10 some kind of currency, right? And then we create our new customer. And then we just call get payment on the Paperboy with the amount that we're interested in, and the customer is supposed to pay. And then we should get the actual number afterwards. We're checking the state now. How much money does this Paperboy actually have after the transaction? And assert that this is correct. Okay. This is one way of doing it. We're checking for state. How could this be implemented? How would this be implemented? One implementation could look like this. We have this Paperboy. We know how much money it has. He has, she has. Paperboy, probably he. And then get payment. We'll ask the customer for its wallet. And then, if the wallet contains enough money, then we would subtract from this wallet. That is basically handing the wallet to the guy behind the counter. Please, take my money, and I'll do something else while you do it. I'll trust you. Would you do that in a store? I guess someone would. I might not. And this is very similar, or this is actually the exact problem I'm talking about. The Paperboy in this case is reaching in to another object, poking around for the information he needs. That's not a great way to do this. The better abstraction would probably have been to have the customer produce this amount somehow. And the Paperboy doesn't have any reason to care. So if we do the same thing with an interaction verification instead, it could look like this. We create a Paperboy, and then we create a mock of the customer. And then we tell the Paperboy to get payment. So we have basically the same API, payment customer. And then we just verify that the customer has been called with get payment and the parameter of the value. We don't really know if this is correct or not, but we know that this code will verify that we have wired up the system properly. And in this case, we could implement it like this. Get payment is an interesting method here, of course. So we have an abstraction here, get payment with some kind of amount. And if the amount is the same as the requested amount, then we're happy and increase the money that this Paperboy has. So this is using abstraction instead of reaching in to the customer and getting the wallet and then getting the money. So it is possible if you add the correct abstractions. And it's always a matter of correct abstractions. So what should we be looking for then? What signs are we interested in looking at? if we think about tell, don't ask, then we might have multiple calls to the same object. And ask yourself, why do you need to interrogate this specific object? What is the reason for that? And wouldn't it be better just to get what you need directly? Probably. Therefore, add a method that actually returns what you need instead of something else, instead of interrogating something. Suppose that you need a lot of details from an object. Suppose that you're calculating the insurance risk again, therefore asking for age, driver's license, accidents, so forth. And then you're probably lacking this abstraction. And if you need a lot of details, well, add a class that contains all these details instead of returning a lot of primitives, and then do something with all of these primitives. Again, a method, but actually do what you want, not something else. Train wreck code, we saw an example earlier, a couple of examples actually. And this is obviously some case where you're interested in something that isn't exposed, but it's possible to reach. Again, add an abstraction. It's easy. So the solution is almost always more abstractions. This will lead to more code, unfortunately. But it will be easy to understand, and they're also easy to maintain. And this is perhaps the most important things, understanding code and therefore being able to maintain it. And if you have to ask for permission for doing this, well, don't. Just don't. Do it, and if the situation occurs, apologize for doing it. This is the way I tend to do stuff nowadays, and it's very seldom that I have to apologize for stuff. But it happens, which is of course unfortunate, but that's better than asking for permission every time, because then I wouldn't get anything done. So the conclusion here is tell objects what to do, don't interrogate them. Ask them sometimes, but again, don't interrogate them. And it's okay to receive response, even if the title of this talk is tell, don't ask. It's not okay to ask over and over again for more and more details. That's illegal. Just don't do that. And it's not okay to dig deep into another object and reach whatever you need. Has anyone heard about the debate about Java unsafe that will be removed in Java 9? Oh, okay. There are functionality hidden in a package called unsafe that some framework developers want to use. They've used it. And now they're very upset when Oracle has decided that this unsafe stuff has to go. Solve the problem without using stuff that you have to dig for. It will be a problem in the future. And be very pragmatic if you can. These are guidelines, not rules. If there's a good reason not doing this, or if there's a good reason to break the Law of Demeter, well, do it. But you should know why. You shouldn't do it by accident, because then it's not okay. If you're interested, there are a couple of books that I would recommend. Test Development by Ken Beck. Really thin book, lots of good information in it. Growing Object-Oriented Software, Guided by Tests, by Steve Freeman and Matt Price. If you haven't read it, then this is something that you really want to read. It's not an easy read. A lot of details, a lot of information, but it's well worth your time. Pragmatic Programmer came out 2000 something, 99, great book. And if you're interested in the 4 rules of simple design, then Corey Haynes wrote a book not too long ago where he talks a lot about it. It's an e-book, it's not very expensive. You can read that one on the way home from here. Well worth your time. So, I'm still Thomas, still independent developer from Stockholm, and I think I'm a bit early. Yes, I'm a bit early. So do we have any questions? Yes?
That incredibly chained example you gave.
Yep.
Would you essentially, you've got transport.getPlace. Would that essentially just go to unit group.getPlace, unit getPlace, and just
yeah, that was the abstraction we were lacking,
yeah.
And I didn't realize that at the time.
Yeah, but you would just effectively go.
Yes, I would do that. Yeah, and therefore just talk to my immediate collaborator, and not in the next generation.
Yeah.
So yeah, and that's the reason why this would add more code, because well, every new method is obviously more code, but for the one that uses this abstraction, it gets a lot easier. So therefore, that would be probably be a good idea. Other questions? Other questions? No? Then I guess we're in for an early coffee break. Thank you very much for listening.
You're James Williams. Oh, hi, James. Why are you wearing shorts? Yes. But there's no
just that.
tickets, yeah.
We were doing get child.
Oh, is it?
Yeah.
Well, she cheering, is she? Just about to get Excel. Yeah, do simple sort just there.
That I wanted, and you got witnesses. Did you stay?
Well, I didn't stay that long, but did stay. We just had a picture. We went upstairs, it was quite nice. We went upstairs where you could look over the picture and everything. And you got a free beer.
So did you have some food as well?
They were just little teeny tiny things.
Oh,
teeny
like
tiny things that make them incredible. You get lunch. You get lunch. There's a buffet. Yeah, there is lunch. There were some pastries. There were pastries.
Just there.
There were pastries. In the middle there. Coffee. Is that right? It's all snags though, isn't it?
But the thing is, it was a long night, but this cake was a long night, but those chargers. So I borrowed the cake.
Wait, I'm not sure which one it is. Is it, oh, you've got a black and a grey? It doesn't keep changing.
If I do at a festival, they sort of do things fancy what it's been. Well, it's warmer today. I was freezing yesterday, so I'm dressed up all warm.
I think they've changed the aircon.
Aircon, yeah, I think I have, haven't I? Yeah.
No, sorry, so Miss Brown, you know yesterday, it's going to change it.
It was chocolate and Stuart.
They did a swap.
Chocolate.
Oh, right.
I couldn't get you in time.
Well, I looked at the other bit, I'm not interested in the store slices, and I just when I read
the